it spreads, and lost his life helping others. With me now is Jason Hargrove's wife, Nisha Johnson Hargrove, and Jason's very good friend and fellow Detroit bus driver, Eric Colts. Good morning.
Good morning. Good morning. Good morning.
I know words don't do anything, but I'm just so sorry for your loss to both of you. And Disha, let me just begin with you. I mean, April 19th, a few days ago, would have been your 12-year wedding anniversary. Tell us about the man you loved.
Gentle giant, very loving, hardworking husband, friend, just all around great man. Just all around great man. Sorry, just a wonderful father. And like I said, just to everyone that knew him, he would make you laugh. He was a lover of music. So just a great guy.
Eric, you guys were so close. I think you went to high school together. You both decided to be bus drivers together in 2016. And you talked about the
Jade. Jade on. I have my class. Okay. All right, Clay. Hopefully you should be able to sign the roll at this time. I'll just put it in the comment. Wait a few more minutes for other people to log in. Yeah, okay, 8 people.
This is Sylvester.
Yes, who's this?
Mr. Gyro.
Oh, what's up, Mr. Gyro?
I'm trying to sign into the role, but it's not allowing me. It says wrong.
Probably because it's right at the 10 o'clock hour. Just try it again.
All right.
And see what happens. Did it give you like wrong hour or something?
Wrong minute.
Yes.
Minute?
Okay.
Yeah.
It just allowed me to sign in.
Right, yeah. See, I guess it was just close to the hours, to that.
Okay, there you go.
All right. Yeah. What's up, Miss Pullet?
How you doing?
All right. Okay, I got 9 people. All right, hopefully everybody's signed. Last class period, we talked about passing of variables, all right? And in passing variables, we know we're dealing with functions, all right? So passing a value of a variable. So normally when you're dealing with passing the value of a variable, let me move this out the way. I'll try to open one of these projects, this function. All right. So if we look here, excuse me, we have a program that actually has a function called number, okay? Now, if we're looking at this, nothing is being returned. We don't have a returning value back to our calling function. But we are passing an int variable, all right, or int value, okay? So if we look in this program here, we have, and this is the main, So we have this function declared. In the main, we have int x equal 100. Okay, so we starting out x as 100. And then I just said cout initialize value of x. Okay, I'll just comment this out for now because we're not dealing with that right now. All right, what's this? So I outputted the actual value that x is equal to or initialize here. But what we're gonna do is we're gonna call this function called number, and down here number is multiplying x, but x is being passed to this int variable called x, all right? And I'll just cout x here. But now, and we'll talk about something before we do that. Okay. Now, the thing is, here, x is a local variable. Can everybody see that? X is local to what function? The main function. X is not known anywhere else in the program because it's introduced where? Inside the main. So the scope of x, meaning where it's known, is in the main. So we're passing 100, which is the value of x, to a function called number, which we introduce it, in which we are introducing another variable called x. All right. So this x and this x is different. Notice how we saying int x equal 100 here. We pass an x, but then we pass an x into this new variable we introduce and call x, so we can use x in this function. Now, I can pass, oh, my phone's still on. I can pass, another student, where they can't log in. Let me check this real quick. Oh, no, I don't have nothing to do with the class. Cut this off. All right. So I can change this name because this is a different scope. I could do, yes.
I was trying to cook breakfast before my class started, and I had to start over. I messed up.
Messed up what?
I'm saying that I was trying to make a big pancake, and all it is still the what I had started off with, the batter.
Mr. Pulley, we hear you.
My class, I'm listening to him now, but I'm saying I was trying to cook before 10 o'clock and messed up.
Okay, so now what you want me to do?
I was gonna ask you, do you want to come up here today?
Okay.
Yeah, that's what I was gonna. That's what I was
Miss
gonna
Pulley.
ask you. Sir?
All right.
We can hear you. You could have muted.
Oh, sorry.
Yeah, all right. So now I could change this variable name here because I'm introducing a new variable. All right. I could have called it num. All right. So, but if I introduce a new variable in this scope, then what? If I'm passing 100 here and I'm trying to multiply 100, I would have to change these are the variable name here to num, correct? So everywhere I use x, now in this scope, I have to use num. What's happening? All right, and when I output, I'm still gonna have to output num. So what happened? I have a variable here. It's global. I mean, not global, excuse me, it's local. Now, I only can use x within this function. I'm calling number, and when I call number, it's gonna pass x to this function, or the value of x, not the variable, the value of x. All right, so it passed the value of x into a variable called number, or num. So now num is equal to x. So what would happen here, it would say 100 is equal to 100 times 100, and then we'll output that value. Okay, that's a local variable. So let's run this and see what happens. All right, so if we run this program, see here, the initialized value. This is what we initialized x to equal to, and which was 100. We called this function called number. We passed x into a variable called num, which is in a new scope. So we use num. We could have used x. I'll change it to x, back to x, and show you that it will work. And then I outputted, I forgot x here, but I outputted num. Now, so let's do this. All right, this is where I'll show you what I mean by that local variable. I'll go back and change this to x, because sometimes students get confused when they may see code and they pass in variables and they say, well, I have to pass it to the same name. No, you do not, because this scope is different from this scope. All right, the value you're using is the same, but you're working in a different scope. Now, but check this out. So right now, x is equal to 100. We initialize it to equal to 100. We output the original value of x, okay? Now, look here. We're calling this function called number, and we passing the value of x into the value of a new variable in a new scope called x, and then we multiplying x times itself, and then we outputting x. But we returning back to the main function, and we're gonna output x in the main scope. Now, how many can guess what probably will happen? Anybody? Okay, so what would happen here, being that we only passing the value, in this scope, x is equal to what? 100. We pass an x to this function. This is a new variable. So in this function, x times x is 1,000. So now x is 1,000, but it does not have any bearings on this x. Different scope, different variable. So when we come back and see out x in this scope, x should still be what? 100. So everybody understand it. I'll run it and show you. So I'll run it. All right. So look, the initialized value of x is 100. We pass 100 into the x variable in numbers. We multiplied 100 times itself, and we got 10,000. But then we return back to the main function where we had to leave this x alone, and we went back into this scope, and in this scope, x is equal to what? 100. So when we outputted x, we outputted the value of x in this scope, even after we passed the value to the other to the function. Anybody got any questions about that? Any questions? So you got, remember we talked about scope, a scope before. So that scope, and when you're using those same variable names, you can get somewhat confused with a program when you're looking at that program and you see that same variable used in various functions. It may not have the same value in that function if you're doing some type of manipulation to that value. All right. So, but this is the thing though. What I'll do here, if I made x global, all right, this is local to the main. If I took this out, all right, and then I made x global, then now x can be used where? Anywhere in the program, which means now I could write my program without what? Having to pass the value of x, because x is known and can be used where? anywhere in the program. So what I just did was I removed the argument list. The argument list, we say we was passing an int because it was what? It was local. Now it's global, all right? X is global. So I could use X anytime I want, anywhere I want. So in here, when I see out X, it's gonna see out what? 100. When I call number, I'm not passing anything, but when I go to number, it says X equal X times X. So X will change to what? 10,000, right? But then when I return back to the main and see out X, it's gonna print out what? 1,000, because X is a global variable. Whatever I do to it is being done at all stages, at any time, because it's global. All of these functions can have access to that variable because it is global. And anything that's normally declared outside of any function, the main or any other function, it is global. All right. So if I run this, I'll get the 100. I'll call number, print and multiply it by itself. I'll get 10,000. I'll return back and I'll get 10,000. And let's run it. And anybody got any questions about this? Because you're going to see that in your program. So look here. We initialized it to 1,000, but it's global. It's not local anymore. So whenever we use it, it's going to change. X is equal to 10,000 because we went to this function and said 100 is equal to 100 times 100. All right. So we got the 10,000, which changed the value of X. Now, when we return to the main function, X is still global. So what was done to it anywhere in the program before we came back here to print it out, it will change. And so we printed out what? The 10,000. Okay. Any questions? Questions? All right. So we saw where if it was local, we had to pass the value. Okay, we had to pass the value. We had to do the data type here. We had to pass the value declare it inside the function, and then pass the value, a variable, which was the value of the variable, and then we had to introduce a new variable and then calculate what we had to calculate. All right, but when it's global, you don't have to pass anything. You just use the variable, and it's no problem. Now. Let's go back to the notes, because the notes going to talk about a lot of that stuff. So local variables.
I got one question.
Okay, I got you. What you got?
I remember maybe it was in the class before this, but you said it was like bad practice to, well, you just can mess up if you run a bunch of global
variables trying to pass them, right? And the reason being. Okay, say I have maybe 5 other functions. I'm using X as some kind of a value or whatnot, but then I have 5 other functions that I'm calling, correct?
Right.
And if I'm passing X and it's global to those different 5 functions, it may come a time where I do X++ or something within that function, and I don't recall doing it. And then, it may throw something off, being that I'm not keeping track of what X is. But if I set it to be that local value, every time I call it, I'm calling that value that it was in that main function, or that function that it was called from. So I'm controlling myself from changing the value, and even if anybody else tried to interject code in your program, it's gonna control them from actually changing the value at that point, just randomly. You know what I'm saying? But if it's global, they could just change it, and then the whole program is just changed.
So my question is, should we take the time to practice using like variables other than global? Because
yes, definitely,
it's easy to just load up a bunch of globals and run the program.
Correct. Definitely, because what happened, and you're gonna see and understand when you start doing that. It's like, oh man, I forgot I was adding to this or doing whatever, and I want to go back to my original value, or I would have made a mistake if I would have had it global. You understand what I'm saying?
Right.
So it kind of protects you too, as the programmer, from when start writing all this code, and then all of a sudden you're making changes. And it's changing the value, and you're like, man, why I don't want it to change it when not. So you can control that. You can control that as the programmer. All right. So now one thing you can say, well, this is best if I do that. If I make everything global, and I guess I'll do that before we go back to the notes. You make it. I mean, you make everything local, and you say, but Mrs. Sylvester, when I pass X, I do want it to change. Right? You might have 10 other variables, but you got that one variable that you do want to change when you do some kind of manipulation or calculations, right? That can be done simply by passing by reference. Now, so what happens is, let me take the program back to the way it was somewhat. All right. So now, here, now it's local to main, right?
Right.
It's local to main. So, and what I said was, whatever I do here, when I do something here, it will not change, because when I return back here, X will be what? 100, correct?
Right.
Like if I print this, I'm gonna print 100. Call this function, multiply this, because it's passing into this new X, and it's gonna change X to 10,000 here. But when I return back, X is gonna be what?
100, right?
100. So if I have all these variables and I got that one variable I want to change, what you do is you could pass that variable by reference. When you're passing by reference, you're referencing the address. So now whatever you do to that variable is done at that address stage. So it will change the value. Got me? So now, just pass something by address, you just do simply, we're doing the same program with this. You do the data type and you do the ampersand. The ampersand here in this function declaration saying we're passing an int value, but we're not passing the value, which is 100. We are passing the address where X is, where that variable is stored. Okay?
Right.
Now, when I go to my call is done the same way, all right? But when I go to my my actual function definition, I tell it which variable I want to reference, or that I'm passing the address, all right? So now I could still use X, but this is it's a new variable, but I'm referencing what? The address. It's a different variable, but what? I'm referencing the same address. So I'm not referencing 100, I'm referencing the address of X. Okay? Now, so when I reference the address of X, now when I do this, I'll get 10,000. And what happens is, being that I reference the address, when the value of X here gonna be 100 times 100 to give me 10,000, it automatically changed the value at that address. So it'll print 10,000 here, it'll return back here, and also print what? 10,000. You got me?
Right.
All right, so when I run it, okay, all right, let's run this and let's see what happens. So see what happens this time? It was initialized at 100. We passed it by reference. So that means if we pass it by reference, whatever we do to it, when we pass it by reference, it will change it at its address. So it will change the value. And so when we return back to the main function, it said we passed it by reference, we multiplied it by itself. So when we did this, it automatically changed the value of X. And now it'll print, when we go back to the main function, it's gonna know that X was changed here because it was passed by reference. Yes, ma'am, Miss Pulley.
If you have time, could you go over chapter 5 programs?
Oh, the program? All right, okay. Because I want to do that, and I also want to go over the chapter 6, because I put them out right before we logged in. All right, yeah, I could do that.
What's that ampersand? Like, what are you doing when you are you modulating that?
No. Remember, modulus is the percent.
Percent sign. Yes, right. Excuse me. What are you doing with the ampersand sign? What's that?
Okay. How would I say it? You remember in the beginning of the last class, when last class 192, and then this class 193, at the beginning of the semester, we talked about high level language and low level language. Remember we talked? Now, C++ kind of is a mixture of both, high level and low level. When you are writing code and you coding and dealing with at memory locations, that's low level coding. Okay, so the ampersand says what? Okay, let's take it like this. Say we have int x equal 100. What is actually happening when we do that? Somewhere in our memory, the computer will allocate what? A memory location, correct? Somebody feeding back. Somebody got their mic on or whatnot. Hello?
Hey, sir, it's me.
Okay. Yeah, just I guess you have to turn your speaker down or something.
That was the TV.
Huh?
That was the TV on my phone. I'm sorry.
Oh. All right, we got no, but you might have to put earphones on or something.
You can just mute your mic on Zoom when you're not talking.
Yeah, that's another thing too. Yeah. But it should work either way. But if you do that headset away. Yeah, Mr. Singleton. Mr. Singleton.
Yes, sir.
Yeah, you still you still my voice still bouncing back.
I'm sorry. Let me check.
So just mute yourself until you're ready to talk. All right.
Okay. Yes, sir.
I can still hear you. All right, let's go. All right, we got it. Now, so we said int x equal 100. The system, the operating system says, okay, they're introducing a variable called x. All right. Now, it allocates a memory location for x. Okay, what's the type data going into that? When the memory location is a memory address. So it says, okay, what's the data type for that memory location? Int. So nothing but a what? Int value can go into that memory location. Now, we also talked about the size of allocated memory, right? Remember we said a char value takes up how many bytes? 1. A short data type takes up how many bytes? 2. So the system is doing all that for you. But at the same time, when you declare a variable, you're declaring that memory location. Int is 4 bytes. So when we say int x equal 100, the system says, okay, I'm gonna find free memory on space in my RAM, and I'm gonna even on my system, and I'm gonna allocate it or reserve it for the variable called x. So when the programmer references x, I know what where to go get that 100 and use it. Now, when we use the ampersand, what it's saying is, and I said ampersand x here, it says, okay, I'm not actually going to get the value of x. I'm going to grab that memory location of x. And I know if I'm going to the memory location, I grab the data, know the data type, know the byte size and whatever, and I manipulate the value at that memory location. So you're writing code like more or less low level language in a low level of form.
Right. So like in this code right here, int really isn't established until we run the program.
What's that?
Because and then, or excuse me, X isn't there until we run the function number, right? And then, or so that's why in the top void.
X is established in main.
But I'm saying in the top void number where it says
right. Yeah, you don't know what variable. Because I could change my program here and change it to something else. Or they got something called overloading. I could call that function number and reference different values each time. If I had int X, Y, and Z, you understand? I could call number passing X. I could call number passing Y. I could call number passing Z. You understand? Calling that same function. All right? Right. So stuff like that. Yeah. But if I'm using the ampersand, I'm using the what? The address, the memory location, not the actual value. I'm passing by reference. All right. Which and this is the thing with low-level coding. It might be a little difficult coding with low-level programming, but it runs faster because the system have to do less. Okay. Your code will run faster. Now, we don't create large programs, so we can't really tell. But I'm saying when you start creating programs and larger programs or not, you rewrite them in low-level language, they'll run a whole lot faster. All right? All right. Any other questions? All right. So everybody see that if I pass by reference, that value will automatically change throughout. It's almost like I'm making it global, all right? Because when I use it and I manipulate it, it will change at that address, all right? But I still would have to pass it to use it because it's what? It is local, all right? So local variables, all right? Variables defined inside a function are local to that function. So that's a local variable. It has to be defined inside of a function, okay? They are hidden from the statements of other functions, okay, which normally cannot access them. And that's basically what we just talked about. If something is local, you cannot access it by another function unless you pass it by reference or by value, all right? All right, and it tells us here a global variable is defined outside of all functions. All the functions in your program is defined outside of the function, and it is accessible to all functions in its scope. So any function that you use it in, it's available. All right. Local variables. Okay, we just talked about them, and we said local variables only within that function that they can be used. Outside that function, it's not known. All right, you got to be aware of that. Okay, initializing local variables. Okay, we initialize a local variable, and which we did in X equal whatever. But then what? In order to use it, we had to pass it to a function because what? It's not introduced automatically to the function that's being called because it's not known by that call function. All right. So it says it is possible to use a parameter variable to initialize a local variable. Sometimes this simplifies the code in a function. For example, recall the first version of the sum function we discussed where we had int sum, int1, num1, int num2, and then int results. And then results is equal to num1 plus num2, and we return results. So what happens here? Results was a value that was introduced inside this sum function, calculated by num1 and num2 being passed to that function. But we return the sum of those two numbers. All right. So the result was introduced here, which is local. All right, but it was passed back to the other function. And I could show you how that's done. All right, and I think we did it, but I'll show you again. All right, so what happens is if you're returning a value, many times I may not want to, well, I'm going to take the ampersand off because remember what happened here is if I write the code in this fashion, all right, when it out going to initialize to 100, I'm gonna call number. It's gonna pass 100, multiply this. It's gonna print out 10,000. But when I return back, it's gonna print out what? 100, because what? This is local. But if I do this, I can. I'm gonna just take this out. All right. I'll leave it in because you might be confused. I want you to see. So let's run it. And then what I'll do, I'll add a statement in the other one. All right. So we know that what? It's 100. We pass it, we get 1,000. But when we return here, we get 100. But check this out. What I can do something like this. I could say int result, and I could have did it all at one time. Int results, and then I could say results is equal to. All right. So now what's happening? And I could have say int results equal to this all at one rather than do two statements. Now, but then I need to do the return. Let's say, and what type data variable I'm returning? I'm returning an integer type data, int. All right, so I have to match this with int. All right, so when then I need to tell it to return x. So now, so I have my program, I have a local variable, all right, but what? In my declare, I have int. If I have int, float, bool, char, whatever that data type is, that's the type value I'm returning back to that the function that called that particular function. So, I'm returning an int, but when I call this, I'm passing an int. So look here, int. Okay, I'm returning an int, but then what? I'm receiving an int value so I can calculate. So looking at this program, and I'm gonna print out results. So I'm gonna print out x, and I'm gonna print out results. So you can see what I'm talking about. All right, and all right, so what happens is we know that this is a global variable, all right? We passing, we're saying, okay, we outputting that 100. Then we calling num sub x. Well, calling num and passing the value of 100. So when we get to this function, 100 is being passed in the x, 100 is being multiplied, and it's being stored in the x, and it's printing out 1,000. All right, 10,000. Then we said we want to return the 10,000 because in this function, x going to be equal to x 100 times 100, which is 10,000. So now when it returns that 10,000, it's going to return it into what? The variable results. And now when we return here, x is still going to be what? 100 because it's local. We didn't pass by reference. And results going to equal to 10,000. So let's run this program. Hopefully I got all the errors out. All right, so look here. The initialized value was 100. We called the number function, all right? And we got 10,000 for x. But then once we returned x back into the main function, into results, and then we printed out what x was when we returned, x was still what? 1,000, 10,000, 100. And then we printed out the value that we sent back to the function, or returned back to the function, which is 10,000. All right. So that's how you can return a value, and you can return an int, a float, etc. All right. But you only can return that one value. All right. All right. Now, and we say global variables, man, global variables, you're free to do whatever, whenever, however. It doesn't matter. But like I say, you can run into some major issues when you do that. You got to be very careful because you have to basically know where, what, and how all your functions are working. It's almost like writing a large program with 100 or thousands of lines of code without having functions. That you got to keep track of that variable and that value so that you won't try to add when you modifying your code and you forget that you have it global, or you in doing something it can cause major issues. All right, and look, and it tells us debugging global variables make debugging difficult, and that's just a known fact. All right, any statement in the program can change the value of the variable, and you might be overlooking it. It could be in the first function. It could be if you got 10 different functions, the last function anywhere in the program. You just don't know. You just have to find it and find where you need to make those changes. So it just makes it difficult. Okay, functions that use global variables are usually dependent on those variables. And what that means is, okay, if I'm passing that value, what I'm doing within it, it depends on those values. Okay. And like I say, but many times you don't want to have everything to be global because you're going to run into issues. All right. Global variables make a program harder to understand because, like I say, it's almost like not even writing using functions, because you just got one large program. All right. Which is a disadvantage to itself. Global constants. We know we could always create constants in our program. And a constant, you just use the what? The command what? Const. All right. If I do const int, and I'll say nums equal 10. So that means what? Throughout the program, I have access to what? NUMBS, nums, and it will always equal to 10. Sometimes that's a good idea. You know, you're going to be using it, all right? Say like when you're writing code for a bank, dealing with interest. You might have different functions throughout the program, and if the interest rate is the same, then if you make it global, you can always just access it anytime you want. So sometimes it's beneficial to have global constants rather than having to try to pass a value that you know will stay consistent throughout the program. You know, it just in some cases, you know, right? But like I said, you don't want to just write programs and make everything global constant or whatever, and then now you got to change something or whatever. So you gotta be wise in when you're doing it. All right, and like I say, a base pay. If you know, like you have a standard base pay, something like we do with minimum wage. Minimum wage might be a base pay. You said that, and that's done. So no matter who's hired or whatever, if they're hired in that category, we know it's globally set. Whenever we could create other functions for that type of employee. We know that their pay is constant and it's accessible because it's global. We don't have to try to keep passing it, add new arguments to whatever and whatnot. All right. Okay. So what are local and global variables with the same name? We did that program. All right. We did the program where we had the same name when we passed X when it was local, right? We use X in the main function, and then we use X in the actual program. I mean, the call function. You can do that, but just know that it's really a new variable because it's a new scope, all right? And then when you're dealing with global, like I said, same thing, you know, you're dealing with your scope. But I said you cannot have two local variables with the same name in the same function, you know, and so that's a standard. You know, you got to have two different ones. But like I say, if you create another function, all of a sudden now you can create the same variable names in that new function, because it's a different scope. All right, this applies to parameter variables as well. A parameter variable is, in essence, a local variable. All right. So you cannot give a parameter variable and a local variable in the same function, the same name, right? So what it says, however, you can have a local variable or a parameter variable with the same name as a global or a global constant, okay? Or when you do, when you do the name of the local variable, local or permanent variable, a variable shadows the name of the global variable, okay, or the global constant. This means that the global variable or constant name is hidden by the name of the local parameter, right? Parameter variables. And then it says, look at this program, all right, where you have birds, all right? So we have const int birds equal 500, okay? We have a function here where we have, it's called California. We're not passing anything, and we don't have any, we're not returning anything, and we don't have any parameters, all right? But birds is constant, and it is global, equaling the 500, all right? So now, in California, what? This is a new what? That's a new scope, correct? So birds here and birds here are what? Two different variables, all right? Because birds here is of a different, well, this is the main. I mean, this is a global variable, but then what it says, this one shadows the other one because this is a new this is a function. So now I have a constant that's in this particular scope that I can use. And then when I return back, if this one is no more, and now it'll use the global variable. All right, so that's all it's saying. So look, in the main, there are 500 birds. In California, there are 1,000 or 10,000. So that's all it's saying about that. So there's some tricks and whatever, but you got to understand the rule, all right? Static local variables, okay? If a function is called more than once in the program, remember I told you how you can call a function multiple times, but each time you call it, the kind of like when you have a nested loop. Everything starts over when you have that with that nested loop, when you kick out of it and go back to that outer loop. All right. So if a function is called more than once in a program, the value stored in the function's local variables does not persist between the call function. All right. So it's like this is because the local variables are destroyed. So it's kind of, like I said, it's kind of like when you have that nested loop. If I have x for int x equals 0 to 5, less than 5, and then inside that for y equals 0 to 3, it's gonna do that. It's gonna do x equals 0, then it's gonna fall into y from 0 to 3. But when it kicks back out, x is kind of like renewed. I mean, y is renewed, so x has become 1, and then you're starting over with a y. So what it's saying is everything is destroyed, and it starts all over when you call that function again. It's like you're calling it for a first time. All right. It don't retain like, okay, if x was equal to 5, when I left that function and z was 10, and then I left the function and come back, called it again. No, it was 5 and 10 last time. No, all that's destroyed. It starts all over.
So right? Can you like briefly explain what it works for? Because I just ran into this problem with program 1 of chapter 5, and so you're saying if you just use the loops, it will reset or it won't reset.
It will. Well, what I'm saying, well, I said with nested loops.
Okay.
Right. Because all right, I'll do this.
When you have you off.
Yeah. No. Like when you have a nested loop. All right, if I do all right, if I do something like this, And what I'm saying is in here, and what happened? Yeah, that don't matter. All right. All right. So what I'm saying is, what happens is in this, I'll do. Okay, like when we fall into here, x is 0, right?
Right.
And we fall into here, y is 0, correct?
Right.
Y goes from 0 to less than 3. When it kicks out of this loop and it goes here, x becomes what? 1. This starts all over. And that's what I'm saying. It satisfies this. Once you kick out of this, you starting over brand new. You understand? But now, if you have variables, now that's a different story with this. But I was saying in reference to a nested loop and the variables in a call that's called multiple times, just like that nested loop where y starts over, that's what happens with your variables in a function.
Okay.
All right. All right. And look at this. So look what we have here. Well, we got our main function and it's calling local and it's calling local again, right? So look here. I mean, show local. It's calling show local. Int local equals what? 5, right? A local num equals 5. Now, it's saying now you're seeing out this, but then you set it to what? 99, right? So what? It started out being initialized to 5, right? And then we set it to 99.
Mm-hmm.
So in this function right now, local num is what? 99, correct?
Right. Does it read left to right when it's reading that C outline, or right to left?
I go from left to right. It should output this, and then it should output the value. So now, but when it leaves this function and it calls it again, everything starts anew. It don't start at 99 or whatever. It reintroducing this variable, it C out in this, which is 5, and it's setting it to 99 again. So you understand what I'm saying? It's destroyed and then it's redone again, like it was called for the first time. That's what they're trying to say here. So if I call a function multiple times, it's not going to retain that value unless the only way it can retain this value if I deal with it by reference. You understand what I'm saying? If I pass a value by reference, then all of a sudden everything changes.
Mm-hmm.
You got what I'm saying?
I got you.
That would be something that you would have to keep track of. All right. So that's all it was saying. What would happen is destroy it. It starts over. Okay. Now, what kind of issue you had with your program?
It was if you go back to your GDB. It was like I think it was maybe the function was the where all the math was, and I would call that function, and then to continue that function, I was trying to like reset the values to 0 so that the loops would run again, and it was confusing, but I figured it out using a different style of loop.
What the program was supposed to do?
You got to enter some numbers and then it averages out, but it has to be like int, and you had to use 2 loops nested.
Oh, you had to do the name and then the test scores.
Right, but then once I researched how what the loops are used for, it was easier.
Right, right. Cause look, remember I told you, I think before the end of class, you at this beginning point, I always can add here. And before that ending point, I can add something. You understand?
Right.
So in here, I could say, see out. Okay, I'll just put enter name. We're not gonna enter it, but it'll be a prompt.
Right.
All right. I won't put CN name because I'll have to put string whatever.
Right.
Now, in here, I'll put the C out, I'll put enter score, test score. And I won't put the plus whatever. And I'll do number and I'll say I can't do X plus. I'll just leave it at in the test score, and it should give me 3. All right. So, what's gonna happen here? Let me put an inline here. So, with this program, it's gonna say enter name, all right? Then it's gonna say enter test score, enter test score, enter test score. It's gonna print out another new line, enter name, where X is 1. Then enter test score, enter test score, enter test score. Enter name, then enter test score. You see what's happening?
Right.
But you have to know where to do your average. To do your average, you wouldn't do it inside of the loop where you enter in the test scores. You would do your average once you collect all of the test scores.
Right.
You got what I'm saying? Because you want to collect you want to accumulate. Remember we talked about, like we did here, X equal X, whatever. Yeah. So we did something like total equals total plus score inside of here. Every time I went through it, it would what? Increment the total. Right. But I also needed to do outside this loop, because remember what we said, if I do int, if I type int total equals 0, because what? I have to set this to 0 each time I come back out. Well, I'll do int total, out here, my fault. Int total. Yeah.
I see it now. That's what I was thinking you had
total,
to do. Yeah.
And then in here, before I collect each one of those 3 values, I'll set total back to 0. You got what I'm saying? So int total, then total equals 0. I'm enter my name, then enter the 3 scores, get the average. Come back the second time. Well, for the next name, total has to start back at what? 0. Enter the first name, enter the name, second name, enter the 3 scores, calculate the average with the total, then total, come back, total equals 0. Enter the next name. So you see what's happening?
Mm-hmm.
I have to set that, because what happens is if I don't set total back at 0, it goes, okay, if the first person made 100s, what happened is when I start entering the next 3 scores, it's gonna add to 300, add to 300 and something, add to 300 and something. And when you try to do the average, it's gonna be a ballooned average. You know what I'm saying?
Yep.
Yeah. So that's what happened. So when I run it, it should give me name. See name, score, and it should do that 5 times. I didn't put the C in, remember?
Right.
Name, score. Then that's when after that you calculate. Set to 0, name, score, calculate, get the average, print out, set to 0, name, score. So you'd have to do that, repeat that the 5 different times based on this logic. Yeah, based on this logic. So you have to do a little thinking, all right? Everybody done that program? Most people muted. Yeah. I could reopen the program for y'all to work on, if y'all want to work on it, But that's some of the things you got to do. And that all that is computer science, kind of knowing, okay, and it's like, how would I say? It's like taking a pencil and paper. Okay, what's the first person name? Okay, what do I need to do? Okay, I got to get a total, but I got to get a total of what? 3 scores. Okay, get the total, get the average, print it out. Then now I need to do the next student. But then I got to remember his total should be 0, should total change. So I got to, in my mind, keep track of all that stuff. And I'm going through the process. Many times what we do, and it's just human nature, we take for granted a lot of things, you know, whereas a computer going to do exactly what we tell it. And that's one of the downsides. You know, we think, we go, oh, well, you do it like this, do it like this. Okay, but what about setting it at 0? What
Be a
about
benefit too, though.
Huh?
It could be a benefit too, though.
Yeah, it is a benefit because we get to realize exactly what is going on. Right. Yeah, you're right. Yeah. So, and it's talking about static value. Now, let's say static, meaning that it's a value that's given, you know, that's there, you know. So default arguments, we did the default arguments where you had well, no, we didn't do an actual number. You could do numbers, but we normally teach you where you use the variables, all right? Because look, void, nothing being returned, show area, and then you got double 20.0 and 10.0. But then when you go to your actual function definition, your definition should have double and a variable name and double and another variable name where they will accept those values, okay? So that's what they're talking about here, able to get their length and width. Because look, so what happens if you see here, double length, 20 is going to be placed, well, 20.0 will be placed in length, and double 10.0 be placed into width. So what but this is kind of like dinosaur programming, but sometimes you can write, because what? You cannot change these values. So that's something, you cannot change those values. Every time this function is called with this statement, it's going to pass 20 and going to pass 10, all right? But you know you can use variables, all right? But you can use values also, you know? Like I could do show area when I'm calling it, I could pass 12.0, but I could pass the variable if it's area, if it's length, I could pass length. Set length to 12.0 and pass length. All right. All right. Now, so see how look, they actually call this function with nothing. Call this function and pass what? 5, and call this function and they pass 7 and 3. All right. Right. But see here, void here. What is start? They pass in 10 and 1. All right. I don't know, columns and rows. So based on this, whatever we're going to be passed into those. Here, nothing is passed. Okay, going to take the default column and rows, which is here. All right. Then take the default rows. So it'll pass the 5, which would change this, but the default, which is set up here. And this one is going to change. It will eliminate this because this is a declaration, and it's going to pass these. All right, like override the default. All right, but it's telling you now. This is somewhat like with arrays. We probably won't get to arrays. In computer science, you cannot skip how would I say, a value in a sense. And in arrays, when you're declaring arrays, you cannot do it either. And I think it works for most lists. If you're trying to list 5 variables, int, x, comma, y, comma, z, comma, total. That's 4. But you couldn't just say int, space, comma, x, comma, y, comma. No, because it doesn't know what that first thing is, so it's going to give you error. Same thing here. You cannot just start off with nothing. And in arrays, same thing. You cannot just, when you initialize the values, you can't skip one. You can't skip the first one, can't skip anyone in between. You would get an error, all right? So just got to keep that in mind, all right? Passing by reference. Remember the passing by reference, we use the what? Look here, you can't really tell if you're just looking at the code in the book, but look, void, double, num, int, and that little symbol here, ampersand. So this is a function definition where ref variable or ref var is retrieving the address of a variable that's being passed. And then it is taking the value at that address and multiplying it by 2, and it will affect what? The value of that variable in the call function, all right? So when you pass by reference, it will make a change to the value at that address, okay? So it will make that change. And look, all it's doing here is showing you the format. This would be the actual prototype where you're defining your function like we did. Void, nothing had been returned, double num, and then we got int, and we passing that int by reference, okay? That's all that's saying. Okay, that's all that's saying. Same thing here is the exact same thing, okay? You're passing it by reference, all right? Now, if you look in this program, that's your definition. So let's look at our main. In the main, we should have, here, we have double num, because double num is our function, and we should have an integer value, all right? Which is value, but in our function definition, we are passing value, which is the reference, the address of value to ref var, okay, which we're going to be passing the address, and then whatever you do to that reference variable will be done to value here. So value would change, will be doubled in the main function. When you come back here, it would be double. And we did that in that one of those examples previously. All right. So, and it tells you reference variables. It say, when it says, I want to see what it tells you it's going to change. It doesn't say. We call that function arguments are normally passed by value, which we first did, which means a copy of the argument value is passed into the parameter variable. Okay, when a reference parameter is used, it is said that the argument is passed by reference. All right, so it says whatever this function has been added. Okay, the function asks the user to enter a number which is stored in user num. User num is a reference to the main variable value. All right, and let's see what it says about it. Okay, now it says only variables may be passed by reference, not the numbers. All right, or an expression. All right, everybody get that? Only the actual variable, because what? A number does not have a what? A allocated what? Memory address. Okay, so it stands to reason that I cannot pass something that does not have a memory location allocated because I'm passing the address where that value should be. So 5, the number 5 is a constant value, but 5 does not have a memory location. Now I could say int x equal 5, then I could pass x as a reference variable. Okay. Now it also says when I have user num plus 10, user num is a variable, but user num plus 10 does not have a memory location. User num plus 10 is an actual value. All right, kind of like 5 is a value. If user num is 3, 3 plus 10 is 13. 13 does not have a memory or address location. So that's why you would get an error trying to pass an actual value by reference. All right, but it shows us what, and this is true in all cases. Notice here, they're passing an int value by reference, an int variable by reference, an int variable by reference, and another int variable by reference. So your argument list can be as long as you want it to be. And the data types can be of any valid data type in C++. So I could pass a string, or I could pass a list. Like in my argument list here, I could have a string, I could have a float, I could have an int, I can have a double, all in the same argument list. Or I can say int, float, int, string, whatever it is. I just need to remember that it needs to match my actual function definition when I start defining what my function, what variables of my function is going to be accepted. And also in my function call, my lists need to be the same because I need to pass them and send them to the right position. Okay, so those are some key things that you need to know. All right. Like I say, overloading. We talked about that with overloading, where you can call with one data type, you could call it again. I think with another data type. All right. So let's just look at where it is. Okay, here you got double square, and then you got int square. So what happens? So in this one, it's all dealing with functions, but what? What's the function name? Function name is square. So in this one, I'm returning an int, but it's the same function name, and then I'm passing an int, a variable. In this one, I'm returning a double, but I'm using the what? Same function name, but then I'm actually passing a double variable, which num in here was int and num in here was double. All right. So that's somewhat what overloading is, using the same function name. So two or more functions maybe you may have the same name, okay, as long as the parameter lists are different. So you got to have the same name, but then that list, I might have in one, I'm calling an int, I'm calling an int or int float. The other one, I'm the same parameter but a different type list. So that's overloading, and that's what they call overloading when you're dealing with functions. All right. So, and like I said, the program basically runs the same. All right. So here they got the function definition, but they use the exact same name, int square. All right. Then int a double square. So this was called what? The function name. All right. And that's the overload. All right. So you can't use that same name. All right. And they're just showing the same thing. When you actually call the function, you're passing an int. Just you're calling it that second time, you're passing a double. All right. And both of them what? Defined to do two different things. All right. But you're using the same exact name. Same name. All right. So well, no, we talked about exit already. Exit actually exit you out because I think we did it with the loops. All right, so that exit function exits you out. All right, all right, all right. Stubs and drivers. Okay, stubs and drivers are very helpful. Is a very helpful tool for testing and debugging. All right. Debugging programs that use functions. Okay, they allow you to test the individual functions in the program. All right, in isolation from the parts of the program that call functions. All right, so what they're doing is they just it's just telling you what is to be done. So it's like you're kind of monitoring yourself as to what's going on in the program. So it say, as you can see, by placing actual functions with a stub, you can concentrate on testing the efforts of the parts of the program that call the function, okay? Primarily, stubs allows you to determine whether your program is what? Actually flowing in the proper way. So that's all it is. It's kind of like a tool that programmers use. And normally, what I do, and like I said, it's not stubs, what I'll do, like if I'm having an issue with a variable, like Mr. what? Let me see. Not Masters, Mr. Marler. Mr. Marler had an issue with the total, right? So what I would do if I was writing code and I had an issue with my average or whatnot, I would try to print out total. Wherever I'm using it, I'll print it out to see exactly what was the value. And then when I run the program and it prints out, I'm like, okay, and then I'll put in numbers to try to track. So I might do something like put 1, 1, 1 and see what happened. Oh, it's 3. Let me write that, and then let me go again. Oh, I put in another 1 and my total is 4. So now I'm seeing that what? Oh, it didn't start back at 0. My total is actually accumulate. So that kind of gives you ideas as to what you need to do. Now, it doesn't necessarily tell you where you need to do it, but it gives you an idea as to how you need to set up your logic flow of your program. And that's the same thing here. So you see this here, the show free function is called with the following arguments. So it kind of like lets you know, or at this point, I can do this. And many times when you're writing code like they have this here, you could have, you might not even have the actual logic for adult membership. But when you choose that option, you could have something that say output, you've entered the adult membership function and do like a CN to make it wait. And then hit enter to go back and then choose another option. So that way you know what the actual flow of the program is working. So all you got to do is work on the content of those functions. And what happens is when you're dealing with or you're working with in large corporations or whatnot, normally that's how you write code, because you might have one person working on the main menu driven, the main menu system, or not person, but a group. That's their task to make sure that what all of the programs coming together and the user can access them by doing whatever. Then you might have a team that's working on the adult membership module. Might have a team working on the child membership module. Another team working on senior citizen module. So that way you have all these modules being worked on at the same time. And when you put them together, all they need to know is the function, because they should have parameters that need to be passed, how many arguments need to be passed, how they need to be passed, and you put it together and it should work. All right. So that's how they do it in the industries. They don't have one person working on the whole project from beginning to end by themselves. It's a team effort, all right, which makes it a whole lot easier. All right. Now, that's the chapter. Oh, I need to go. I'm gonna go over the test. I'm not the test. The assignments for Miss Pullet. But let me show you something. The next chapter is arrays. What I'll do, I'll just kind of show you what arrays are, how they work, whatever. All right, with arrays, an array is a let's see. Arrays allow you to have a collection of data stored in one of all of the same data type. Okay. Now you say, well, what you mean, Mr. Sylvester? If I have 10 numbers of integer data type, I can take those 10 numbers and store them in an array of integer, and then I can reference them. Now, the good thing about using arrays is I can read in something, store it into an array, and then use it at any time in the program after that. If you notice, when we write our code now, when we say CN a value, we input that value, and if we don't retain it, the next time we read in the next value, it overwrites that value in that variable name. So when dealing with arrays, same thing as variables, arrays can be global or they can be local. All right. If an array is global, it's declared out or initialized outside. If it's local, that means it's local to that function that you are creating. So how would I create an array? To create an array, I could do something like this. Int, all right, give my array a name, numbers, and all I need to do is the square brackets. Now, there's two ways you can declare an array. implicitly or explicitly, okay? I think what explicitly, then you're given the values, all right? Implicitly, it's like you don't get but you don't give the size, all right? What happens is I can do int numbers, and then I could say equal, and if I do something like this, curly brace, if I do if I type 100, 200, 300, if I could type this thing, 300, 400, and I'll just do 500. All right, 500 curly brace. Now, what happens here in this fashion, I did not give my array a size, but what it will do, it will count the number of elements in the listing and automatically give me a size, all right? But I can also give it the size. I could count them myself and give it the size, okay? I can do that, right? So two different ways you can do it. Let it count and know the limit, or you could type in a limit. Now, when I create an array, I could create the array to be larger than the listing. That's no problem, all right? Everything else is nullified, all right? I got 10 elements. I can have up to 10 numbers in this numbers array, all right? But I only listed the first, 5, all right? Now, sometimes you have errors when you go outside that boundary, all right? You go outside the boundary of the array, now you start getting garbage. So now, the thing is here, if I do a for loop, so I've just declared an array of 10 numbers, but I only have 5. So I could do something like this, for, and I know it's 5, so I can use the int. For int x equals 0, x less than 5, that's 5 times, right? X plus plus. Now, in this instance, I can't say go from 99 to 100. I want not 99, 95 to less than 100. I can't do that. Why? Because I'm going to use this control variable in my loop to access my elements. If I look at this array, this position here is element 0, element 1, element 2, element 3, element 4. So you say, well, Mr. Sylvester, why they don't start at 1? That's just what they do in computer science. Computers always start at 0. So if I wanted to output this number here, 100, I would output numbers sub 0. This is numbers sub 1. This is numbers sub 2. This is numbers sub 3. This is numbers sub 4, right? 0 to 4 is 5, okay? So I could do something like this, see out T, and I'll say, and then I could do something like this, number, and I gotta use the sub and X. Now you say, well, Mr. Sylvester, why are you using X? I'm using X because what? In this loop, X goes from what? Goes from 0 to 4. Get to 5, it kicks out. So if my loop's starting at 0 and ending when it equal to 5, if I go through this, number sub 0 is this, number sub 1 is this, number sub 2 is this, number sub 3 is this, number sub 4 is this. All right, so watch when I run this program. When I run this program, it should print out all those numbers that I have. Hopefully all my errors are out. And my semicolon, me and them semicolon. All right, so let's run it. See what happened? Numbers 100, numbers 200, numbers 300, numbers 400, number 500, right? So if I did this then. So I could print that out. I could even print it out a second time, a third time, or whatever, because those numbers are stored there. So if I go here and do this, I'll say cout just to make you see that it's different. No, all right, and then I'll say numbers. I can type sub 2. Now I put in an actual number this time, right? So now what will print out?
200.
Huh?
200. Oh, well, it's gonna print 100, 200, 300, 400, 500, and then it's gonna print 200 again.
Huh? Okay, let me ask you one question.
Go ahead.
What number does the computer start at?
0.
0, right? Yeah. Oh,
right.
Excuse me. I'm tripping. 300.
Right. You see, so
yeah.
that's what's gonna happen. It will print out 300 because what? Number sub 2 is what? 0, 1, 2, right? Not 1, 2, right? So if I run it, it's gonna print number sub 2. See, which is 300. Right? So that's how arrays work. And like I say, once the values are in the array, they're set, you know? Now, another thing I could do, I could have declared my array, okay? I got a maximum number of array, 10 elements. Now, I'm gonna say this, arrays are allocated in consecutive memory locations, okay? And you'll need to know that for the next class. And when I say next class, the 194. Because arrays are like pointers. What happens is, what's the data type for this array? Int. How many bytes does an int take up, used when allocated?
Forgot.
8.
4.
Oh.
So what happens is, if I say numbers 10, how many bytes, consecutive byte locations I need to create that array?
40.
Right, 4 times 10, which is 40. So what happens is it starts at what? 0, right? Which is the first 4. Then sub 1, the second 4, sub 2, sub 3. Now, if it's in consecutive order, now I should be able to have a way where I could say I want to bump up from sub 0 to sub 6. You understand? And you can do that when you're dealing with, you can multiply, or you can deal with the actual address. Multiplying the address or whatever, but you'll get to that when you deal with 194. But it's important to know that, because what I can, if I had a file and I had, like, say 1,000 numbers, I could make my array of 1,000, right? But if I didn't know how many numbers I had and I made like 40,000, now I'm wasting what? Allocated space. You understand what I'm saying? So that's the one downside with arrays. You never know. Well, once you allocate an array, you can't go back and say, oh, I want to reduce the size. Oh, I'm going past the limit. I need to increase the size. You can't do it. That's the one downside to arrays. All right. So like I say, but you always can go way above. But if you go way above, you just allocating space that you may never use. All right. But the one feature in C++ they use to combat that is called vectors. You got vectors. Vectors can grow or shrink. Like arrays, once you set the size, that's it. But a vector can grow or shrink. You can delete from it, add to it. And then what happens, the beauty about vectors is, once the values are in the vector, you can manipulate them like you do arrays. The coding is basically the same. All right, so It's not that difficult. But let's do this. So I got for whatever. Now watch what I do here. I'll do like say CN. Well, see out. Enter a number. All right. Now, when I do enter a number, now I could do what? CN num. All right. Do CN. Or is it numbers sub what? Sub X. Because what? I can't use numbers by itself because numbers by itself is the entire array. All right? So I cannot do that. So now look. So now what? This loop will perform what? 5 times. Each time, enter a number. And they're going to keep going. Enter a number, until they get to 5. Now why? What I could do after that, I could copy this. And I'm going to just copy it, sake of time. I'm going to copy it. I could go here and I could paste this. And now I could say, see out. Number, and I'll take this off. Because anytime I use number, I got to do number sub X. I can't use number by itself. All right, so now, what happens here, I'm reading in the 5 numbers here, right? Then I break out of that loop, and in this loop, I'm going to write out the 5 numbers. So see, I can grab that data, and then for a later time, I can use them at any time. I could even use them, in a function or whatever. Because remember, arrays are what? Addresses, really, pointers. So whenever I pass an array, I can pass the whole array. It's like me passing a reference. All right. So when I run this, it's going to allow me to input the numbers. What happened? Where am I at the top? Oh, see here, what happened here? Remember I took off my initialization? But when I did that, now it has nothing. So why have an array that does not have any what? Elements. You got me? So I gotta give it a size. All right. So now it has a size. Now I can go in and use what? Number sub whatever. Because when I was trying to do num sub X, going from 0, 1, 2, whatever, then it's like, what's going on? All right. So when I run it now, it should allow me to input those 10, or not 10, those 5. All right, so I'll put 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5. Hit enter, bam. You got me? Oh, we left this other one sub 2. So that's still left. So you see how I inputted the data, and I didn't have to do anything to recall it, but call what? Number sub whatever. Now, that's arrays, all right? And we could, if I told you I wanted you to add these values of these arrays, of that array up, in here, what you'd have to do is what? Perform it 5 times, totally equal to total plus num sub X, and then outside print out the total, all right? So stuff like that. There's many different things you can do. But let's look at an array of characters, all right? So now all of a sudden, I could do char name, right? And I'll say 10. Now, char arrays work a little different from number arrays, all right? Or numeric arrays. Char arrays, I can print out all of the characters at one time just by referencing the name, all right? Or the variable name. I don't have to print out names sub 0, sub 1, sub 2, sub 3, sub 4. I could just say see out name, and however many characters it is, it's going to print it out. All right. So what I can do, I could say, okay, char, and I'll just do this equal, and I'll say what, one word. let's say Mississippi. Well, that's too many common letters. Looking for a long name. I'll say California. Okay. All right. So I'll set it to equal to California. Now notice what happened. All right.
You missed the N. It's not M.
Oh, yeah. You're right. Misspelling. All right. So now, when I go here, now I could do cout name. All right. Well, I'll do the capital line. All right. And I'll say name or state, whatever. All right, and the name. All right, so when I run it, now it's gonna give me what? Oh, it's too short. Man, my fault. I think it's too short. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now, this is one thing with character array. You have to leave at least one space for the null terminator. Why is that? The null terminator signifies the end of the input. Remember when we was inputting our data that time with string whatever? Same difference here. If I don't have enough to store the null terminator, it will not know when to stop the program. All right. So when I run it now, it should give me California. So everybody, you understand? I didn't have to do cout names of numbers, names of 0 whatever, but I could. All right. But what happens is, if I do this, cout name, okay, I'm gonna do a /n. All right, I'll just do st, and I'll do name. And I can do, being that it is an array, and if I wanted to print out the F, that would be what? If I wanted to print out the F.
4.
Right, names of 4, right? Starting at 0, all right? So now, when I run it, so see, I could print out the whole thing by just cout the name, or I could print out an individual character. I could even put it in a loop. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could do the while not null terminator, but I'll just do 10. Okay, for and x, and I'll use x equals 0. X less than 10 or 11. No 10. Okay, x plus plus. All right. So now I don't need the curly braces, right? But I'll just do them out of habit to make sure, I'm if I add something later, it will still be inside the curly braces. All right. So now this will just print the F 10 times. But I'll say what? X, not capital. Now, when X is 0, it's going to print the first one. Go to a new line. Well, let me take this out because I got whatever. All right. It'll print each one of them on a new line. All right. So watch. It's going to print California going running down. So see what happened? It printed what? The first letter, but then I put ST, the second, next line, next one, next. So I can still print them individually. I could even test them. You understand? I could do if whatever is equal to A, or whatever is whatever. I could do all that, whatever I want to do. And when I'm doing this. So like I say, we went over the if logic, the while logic. So now with the arrays and with the function, you see how you can incorporate all that, and almost any type of scenario you need to program, you can what? Take this and put it together to create a program, a workable program. So that's what this is, learning this is about. Don't be so narrow-minded. You gotta broaden your horizon and kind of work with this. Now, so we know string data, I could just say string this and then print that out. And with string, I could do the sub whatever too. No, I can't do that. Because a string is a list of characters. All right. If I have a string array, I could have a name, a name, a name, a name. The first name would be name sub 0. Second one would be name sub 1. Next one would be name sub 2. Whereas with char data, each individual character is a subscripted variable. Okay, so you gotta keep that in mind. All right, and like I said, you could do double. I could have done double number 10. I could did whatever, float, whatever, or any data type, short or whatnot. All right. So any questions? Any questions about the arrays? And like I said, you can look in that chapter, work with it, write up the program that's in there, and ask questions. I think we have one more class period. The practice final will be available next week. I think I made it available next week. Sunday, I think Sunday from that Sunday to the 3rd or that Saturday or that Sunday, one of them. But all next week is the practice final. All right. Anybody have any questions? We're gonna go over those programs. Let's go here. Questions, anybody? So before we get to the programs. All right. So let's look at our, that's not the first one. That's the first one. All right. The first program, and we kind of looked at it already, but we'll look at it again. It says write a program. I'll pull this out. Not here. I'll pull this out. Okay, and I'll do this. All right. So it says write a program using a nested loop. All right. I thought I put this over here. All right. Okay, write a program using a nested loop. All right. Choosing 2 of the 3 loops discussed in chapter 5. Now, what that means, I cannot use 2 do whiles, or I cannot use 2 while loops. I cannot use 2 for loops. All right. I'll use either a while and a for, or a do while and a while, or a for and a while. Everybody understand that? That's what I was meaning by that. I wanted you to practice with using the different type loops. Okay. So it says allow a user to continue calculating the average of 3 numbers entered if their choice is Y. All right. So what happens is, and then it says, and the nested loop will, let's see, and the nested loop will loop 3 times, allowing the user to input an integer value each time. So the inner loop will allow you to input the what? The 3 scores. The outer loop will allow you to input the name and then calculate what you're going to calculate. All right. So what we had was something like this, where we had maybe string. I'm gonna have to do string name, right? And then we had what? We had a score. Int. Well, I'll use int score, and then double, I would say, I'll say total. Score, comma, total. All right. And our total we could set it equal to 0, but we're gonna have to repeatedly set it inside the thing also. Then double average. All right. So these are variables that we're gonna use. But now what? I need to do string. upon include. All right, so in here, all right, you can use I would say use a do or use a while, because what? We prompting each time to continue, correct? Not a for, but use a do or a while. All right, so I could set a value for a choice where I could say, okay, choice equals y, all right? Okay, and then I could say what? While, or I could have done the do, choice is, if I could check, is equal to what? Y. So that's gonna make it what? Fall in, because remember a while is a pre-test loop, all right? So now, we have that. While choice is this, all right, we want to do whatever, all right? So I'll minimize this. All right, so we want to do whatever. What do we want to do? We want to do see out, enter, and I'll put this in here. Enter name. All right. So we'll enter the name, and then we'll do cn name. All right. So now I would do what? A for loop, because I know how many grades or how many scores I want to collect for int x equals 0, x less than 3. Now I could have used 1. I could have went 1 to less than what? 3. So I'll say x equals 1, x less than or equal to 3, x plus plus. All right. So what that would enable me to do is say see out. That would enable me to say see out, enter, and I could say score, all right? And then I could say, I'll do it like this. And then score number, I'm messing up. Score number, and then I could say X, all right? So what that will do, that will allow me to say, see our enter score number and 1, right? And then I need to put a space. I could do it. All right. So that's gonna be a space, and then I can say cn, if I can manipulate these, and then I can say cn score. Now, notice here, this is not an array, so every time I input a score, it will what? Overwrite the previous one with the score I inputted, correct? So now I input these scores. So this is the for loop. This is the for loop to input the name. So if I say yes, I'm gonna input a name, then I'm gonna fall in here, input 3 scores. All right? And I'm gonna do that as long as I do a Y. Now, but I'm collecting 3 scores, but inside of here, I need to calculate a total. So every time I get a score, I need to say total is equal to total plus score, because if not, I'm not getting my total number to do an average. Right? Now, I don't want to do an average as I'm doing the as I'm inputting the scores, because I might have to input 100. It could be 100. Then my program is just calculating for no reason. But after I read in the 3 scores and accumulate that value, now I fall outside of that loop. Now I can say what? Average. Well, I can tell you. Average is equal to total divided by, and I can do 3.0. Oh, it's in the wrong place. All right. This is in the wrong place. Because what? This need to be outside the loop of the input. All right. So that need to be here. All right. So average is equal to that. And I could have made that 3 constant if I knew how many scores I was reading in, and then made my loop perform that constant value here. So that's how you can make your program more flexible. So we calculate the average. Now, once we calculate the average, we need to output the name, output the average, and set the total back to what? 0. All right. So I could do something like cout. Count. All right, I'll do that. Name. Do we what? Start name. I have to move my screen over. I can't see it. Name. Average. All right. Yeah. Now, I didn't print out the scores or nothing like that or whatever. I'm just printing that out. Well, this need to go here. I don't know what's happening to my computer. This here. Cut. Paste. All right. So now, but I also need to do what? I need to do my average. I mean, not my average. I need to set my total score back to 0, because my total at least, because each time I do a new student, I have to set everything back to the original. Name will be overwritten, score will be overwritten, but total is equal to total plus score. So total is being accumulated. So in here, before I do my my for loop for my next person, I need to set total to equal to 0. All right. So now this is the program. So if I run this, hopefully I got all the errors on. All right, enter name. So I'll say Bill. Okay, enter score number 1. If I put 100, hit enter, 100, hit enter, 100. After I hit enter here, it should break out of that for loop, calculate the average, print out the name and the average, and then then go back up, change my counter for my outer loop. Well, no, I didn't finish it because I didn't do the choice part. Okay, so but let's do this part, see if it works. So the average is 100, right? So the thing is, I didn't do the choice part, right? And so it's just gonna continuously loop because I never ask the question, do you want to do it again? So if I do Mary, all right, and I'll say 90, 100, or 10, and 90. All right, they have a 63 point whatever. But in the program, I need to do what? I have while choice is equal to y is always going to equal to y, right? So I need to do something down here. Oh, let me break out. So I need to do something down here to say what? Cout, enter y to enter another student. You understand? So, and now I could say CN choice. So now, if I don't enter Y, then what? It'll kick out. But as long as I enter Y, it will continue. So if I run it, Okay, I'm gonna just do one of them. And I'll say, okay, we'll type Matthew, say, let's say 90, 80, 80, 85, 28. Now, see? Now, enter Y to enter another student. If I say no or any other character, I'm finished. So you see how I use a what? I use a while loop to make it continue to ask me the question, all right, and in the name. But then I did a for loop inside the while loop to allow me to enter what? Multiple scores. And if I had 5 test scores, I would change this to 5. Or I have a constant up here and change that constant value to 5. And then I can just change it up there and it's done. All right? Any questions? Questions? All right. The second and third program, they were pretty much how would I say it? You had to follow instructions. That was the thing with them. You have to follow the instructions, you have to know how to create the data file, know where they are. So look, it says, okay, using the program that reads from a data file. All right. Did we go over the information for data files? We went over that, right? Reading in and writing out data files. That was out there in the chapter 5. So it says type in the program. Once the program is typed, but then you had the how-to video. If you needed to know how to, think under my YouTube channel in my checklist. Let's see what they are. I can't really see. All right, I have this. Okay, creating an individual. If you use visual, you did it this way. But creating a data file in online GDB. Click here, and it'll show you how to do it. All right. So that helped you to do that. But you still have to understand files. So let's go back to online GDB. So, because I think in this one, you had an input file and you had an output file. All right. So if I go back to online GDB, where is this here? All right. All right. So if I go back to online GDB, all right, we go back to online GDB, and now let's write a program with a data file. All right. So we'll take all this out. I could leave it in, but I'll take it out. I'll take all this out. All right. I'll take this out. All right. Now, several things with a data file. If I'm going to use an input file or output file, I need to load the file library. Pound include fstream. All right, that's my header file. I need to load that. All right, now, at this point, I need to know whether or not I have an input file that I'm going to be reading from, or an output file that I'm going to be writing to. Okay. If I have an input file, I would use ifstream and then my input file object. Could be whatever I want. I could say in that. Okay. That's my input file object. Anytime I do a CN, I have to use in that. Okay. If I'm writing to a data file, all right, I have to use my OF stream object. And I could say out that. All right. So now out that would be the object that I'm going to use anytime I want to write my data to my data file. Okay. So I have those set up. But remember what we said. You create the object, but you have to open the file that's going to be associated with that object. So here I would do in that, all right, dot open. And now in double quotes, inside the parentheses, I need to give the file name that I'm reading from. Now, another thing I need to know is where the file located. If I'm working in an environment like this, it's defaulted. It's going to be in my folder that I'm working in. You don't have to try to search for it or whatever. All right. Another thing you need to be aware of is what data are you trying to read? If I'm just trying to read in names, I just read in string. If I'm reading in an int value, a float value, or int value, then every one of my records needs to be int float int, 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 until I get to the end. You have to know that. All right. So say we're gonna read in a name, a age, and a dollar amount, say a balance. So we need to create the file we're gonna reference. We'll call it input file underscore file. All right. .dat. Now I created that name, right? Now I need to either know or create the name of that input file. So here, when I create this new file, I have to make it that same name I just said I'm creating, input underscore file .dat. All right. So when I click OK, now that file is created. If I misspell this file in any kind of way, it won't be able to read this file. Okay. I won't get any data or nothing. All right. So now that's the program. All right. This is the file. So say we want to read in name, Bill. We want to read in age, 22, and we want to read in a dollar amount. All right. Okay. A name, a age, and a dollar amount. A name, a age, I'm gonna do 5 of them. A name, age, dollar amount. Name, age. All right. So now remember, name space, age space, dollar amount. Name space, age space, dollar amount. Name space, age space, dollar amount. Each one of them they don't have the exact same data, but the same type of data. Everybody understand? Because what's going to happen? I'm going to have to read name, read age, read amount. Read name, read age, read amount. Read name, read age, read amount. Kind of like doing CN. Now, the thing is, though, everything is just separated by a space. If I swap these two values, 22 with this value here, and I said this was a string, this was a int, and this was a float, and this number was replaced here, it would read in Bill for the string, but then it would read in 28219 for a string, for the int, and then 28 for the other part, but then now 22 will be the name, Betty would be the int. So you see how your data all of a sudden is thrown off, all right? So your data would be thrown off. So now I have that in there. So when I go back to the program, all right, so I got my int file. So now I know I need to do my variables. So I need a what? A string, name, int, age, and double amount. All right, so I've just declared my 3 variables. Now, rather than me do a CN to input the data, what I'm gonna do is I do a loop, I'll say for, I know I got 5 of them, int x equals 0, x less than 5, x plus plus. Now, what happens here is, all of a sudden now, I would do in that, in that name, age, amount. All right. So I'm gonna input it, but then before I leave, I'm gonna output it. Okay. So I'll go up here and do cout. I'm gonna output name, and I'm printing this. Well, yeah, I'll output it to the screen, then we'll output it to a file. So I'll put name, and then I'll do age, and then I'll do amount. All right, so now, if I run this, I won't have to type in any of those values or whatever. So when I run it, all right, when I do a run, if I don't have any errors, what does it say? Operate. Oh, one thing I forgot to do. No, I opened the file. Open the file for that. Okay, in that. Oh, the amount. This one is backwards. Oh, no, that's right. That's right. The other one, the CN. This one is backwards. All right. So I had my directives wrong. So let's run it. So see what happened? I did not have to type in anything. It went, grab that information from that file. It outputted my label, name, and then what? The first one, Bill. It output a what? Age, whatever that is. And I'll just click here so you can see. See here? Bill, 22, 28,000, what else? It left. I can run it again. It's gonna do the same thing. It's gonna read the file. So see here, each one of them, it read the data and outputted the data what? To the screen, because I use cout. It read the data from the file because I use what? My file object, which is an input file, IF stream, in that, and it read from the file called input_file.dat. I created this name. So just like you create variable names, you create your file name, all right? So, and your file name has to follow the rules of your operating system, right? So here is the output, okay? Now, if I wanted to write this data to a file, I could write it to the screen, but I also can take it and write it to a file. So I'll paste it again, or paste it. And rather than do a cout, I'll do outdata, outdat. Outdat is a file object for output to my file. What file? I never gave it a name yet because I never opened it. So I'll say outdat dot open, and whatever name I give it, that's the file it's going to write to. So here I could say output file, or if I could type, .dat. All right. So what's going to happen when I run this program now, it's going to read from the input file called input_file.dat. Then it's going to write the information to the screen and write to the output file. Read the data, write to the input to the output screen, write to the output file. Read the data, write to the output screen, write to the output file until it do all 5. So notice here I have only 2 files, right? Main.cpp and input_file.dat. This output_file.dat will be created when I run this program, right? So when I run it, oh, I got an error. I put the Mississippi colon. Yep, semicolon. All right, so now when I run it, it's on the screen, but look, output file.dat, it also wrote it to an output file, okay? Now, look at this output file. It's a little different because the tab, and this is the true, I think this is the true text file. So it tabbed over because the character spaces are bigger, all right? This is my input file. This is my output file. And this is my actual output to the screen, all right? So that's how you read data from a file. You gotta have a file, pound include F string. Then if I want an input file, I have to create that input file object. If I want an output file, I have to create that output file object. Me as the user, I'm creating these object names, all right? Just like creating a variable name, all right? Same difference. I could have just used the letter A here, the letter B here. It wouldn't know that, all right? And then, but I have to use it the same everywhere else. But this is my input file object. So what? My in data dot open. And now what's my input file? Input file.dat. That's where it's grabbing the data from. Output file is output file.dat. All right, but my object is out that. Okay? Anybody with any questions? Questions?
No.
Huh? But that's how I know. Everybody did my programs? Hello?
Almost for me.
Huh? So you want me to open them up for another day or two? Because when they
That
do.
would be helpful, yes, sir.
When they
they're
do.
due today, right? Today at 11:59.
Oh, tonight? Yeah. Oh, well, you got time to try to get it done, right?
Yes, sir.
All right. But hopefully this should. Huh?
Since I don't have anything due for today, I can focus on that.
Oh, yeah. But what I was going to say, forgot what I was going to say.
By the next program or?
Yeah, I could look. Yeah, we can look at the next program. Let's look at the next one. The next program. Well, the next one is basically the same, dealing with output. Okay, the output will be created on your computer or compiler, in the directory, whatever. Yeah, but that's input file. But one of them was a input file, and one of them was input and output file, which we just did. So these 5.2 and 5.3 was basically the same, right? But you just had to follow different. One of them had just an input file. The other one had an input and an output file. Okay.
Yes, sir.
All right. Now, chapter 6. Oh no, not that one. Chapter 6. All right. Now look at this one. And this is somewhat of what we talked about earlier today. It says, write a C++ program that will allow a user to input a length and width of a rectangle, all right? So the length and the width. Once entered, calculate the perimeter, all right? And the perimeter is what? 2 times length plus 2 times height times width, right? Now, but you add those double each side and add them. Then output the length, the width, parameter, and area. Now, area would be what? Length times width, right? Okay, make sure that the labels are outputted, or your labels are outputted, whatever length is, width, parameter, and area. It says use a function to accomplish this, all right? Declare your variables as global variables. All right, so that means you don't have to pass anything, right? You're just writing the program and just separating the code, correct? Everybody understand that? So you're just writing the program. Now you're creating a function. You don't have to pass anything, but you need to create the function prototype. You need to do the function call, and then in the function, you need to just put the same statement you would put in if you were just writing it in the main, because the variables are what? Global. Everybody got the meaning of that, right? All right. The next program Look what it says at the bottom. Locally declare your variables within the main function. This makes a big difference, remember? Because now, if I declare length to be equal to a certain value, I can't use length in my function unless I pass that value to that function. I can't use width, unless I pass the width to that function. Now, this is one of the keys though. Perimeter, you don't need to pass, because what? You're gonna introduce perimeter in that function where you're calculating it. Area, you don't need to pass area. You're calculating area in the function that you are calling. So you can do int area in a float, int float area, float perimeter. So now you have those values, and then a variable declared, and now within that function, and now you can calculate it based on you passing the values for length and width. Everybody got that? The first program, the variables are declared globally outside of any function, all right, above the main. This one, the second one, those same variables, now you placing them within the main function, and then when you do your call, you're gonna have to pass, or really, like I say, your perimeter and area, you move those into the function that you create, all right? Because you don't want to pass just a zero values just to be passing them. You create them in that function, and when you leave the function, they're gone. So those are the things you got to do. So one of them is global, and one of them, the values are local. All right? And like I say, you can look at what we did at the beginning of the class with global variables and whatnot with a function. And that should kind of help you and guide you into writing your code. All right? Any other questions?
Not really, but what about the row? I keep forgetting. Since I end up waking up not like a usual time for.
All right, who is that, Mr. Singleton?
Yes, sir.
Take the password. All right, the row. I don't want to view it. I want to add.
So I hope you be careful using Zoom, by the way, Mr. Sylvester, because I know hackers will be coming on here disrupting the class. That's why I'm seeing some videos happening.
They're doing what now?
Some of the hackers are just hacking into Zoom and interrupting classes.
But what they doing in the classes?
I'm not sure. I remember some videos of them just mostly disrupting it.
Oh.
Causing confusion of student body count, what they actually had.
Oh, okay. Yeah. Wait a minute. Do I see your name, Mr. Singleton, right?
Yes, sir.
It's 190. It's 190.
93, right?
Yeah, I'm in 193. What section? Oh, this section 2. Oh, okay, that's right. Yeah, this is the Wednesday class. All right, here we go. All right, today is 04/22. All right, I got you. All right. Any other questions? Yeah, go ahead.
I think I saw like a bonus. Was that already past due or?
No. What I do normally, a lot of times I copy my coursework from the previous semester. Yeah. I don't know. I might put out as a bonus, but I don't know if y'all will be able to do it. If y'all want to do it, you'll be wasting my time. I'm grading it, and it ain't right. Well, I tell you. I think it's this one. See, this one is basically some of the same thing. Write a program that will read in 10 integer values from a data file, while reading in from the data file sum the even values. So look, what you got to read from the file, test to see if the value that you read in is even, then add it to a total. So you got to have an if statement somewhere in there. And, keep reading until you read all 10, okay? But then I say you must complete program, should be program 1 and program 2, programming assignments assigned for a chapter 5 to receive credit. I could put that as a bonus. Some people might do it. Some people might attempt. I might just take points, but I don't get take points. I'll just post it, and it'll be due next week. On Wednesday. I think that's Wednesday. Oh, that was Tuesday. I'll make it due Tuesday before class. All right, and I'll publish it. So y'all can do that one. All right, okay. Let me see. I should make y'all turn in a data file too. Data file. CDP. Take this off. All right. All right. Any other questions?
No, I'm good, sir.
Okay. Anybody else? Questions? Pernell, Williams? Questions? If not, I'll see y'all next week. Do my assignments now. I'm gonna open up those other assignments for a couple of days so y'all can work on them. Well, no, it's open till tonight, so y'all should be able to work, hopefully while it's fresh in your mind, to get it right. All right? All right, then. Yeah, I think they do tonight. Previous. Yeah, it's due tonight. All right. Yeah, 11:59. All right, so I'll see y'all on next class period.
Okay.
All right.
Semester.
Have a good one.
Yep.
All right.